Picture this. You wake up tomorrow morning, check the news, and see a headline that stops your breath. Atlantic Ocean current system has collapsed. Not slowed down, not weakened, collapsed. Completely shut off. The massive conveyor belt of water that's been circulating through our oceans for millions of years has just stopped turning. And within months, maybe weeks, your world becomes unrecognizable. This isn't science fiction. This is a scenario that climate scientists are genuinely worried about. The Atlantic Meridional Overturning Circulation, or AMOC, is one of the most powerful forces shaping our planet's climate. And right now, it's showing signs of instability that have researchers deeply concerned. But here's what's truly terrifying. We have no idea how fast it would happen. Would we get years to adapt? Months? Or would we wake up one morning to find that the climate system we've depended on for our entire civilization has simply switched off overnight? Now, before we dive into the chaos that would follow a collapse, we need to understand what we're actually dealing with. The AMOC isn't just some current flowing through the Atlantic. It's the engine that drives weather patterns across the entire planet. Think of it as the circulatory system of our climate. Here's how it works, and why it's so crucial. In the tropical Atlantic, near the equator, the sun beats down and evaporates massive amounts of water. This leaves behind saltier, denser water. That salty water travels north, carrying enormous amounts of heat with it. We're talking about the energy equivalent of 1 million nuclear power plants constantly churning through the ocean. As this warm, salty water reaches the North Atlantic, something remarkable happens. The cold Arctic air chills it down. Cold, salty water is incredibly dense, so it sinks. Picture a massive underwater waterfall, thousands of times larger than Niagara, plunging toward the ocean floor. This sinking water then travels south along the bottom of the Atlantic, eventually circulating back around to complete the cycle. This process doesn't just move water, it moves heat, massive amounts of heat. The Gulf Stream, which is part of this system, carries more than 20 times the heat transport of all the world's rivers combined. That warmth is what keeps Europe from turning into Siberia. It's what moderates temperatures across the North Atlantic. It's what drives rainfall patterns across Africa, South America, and North America. But here's the thing that makes scientists lose sleep at night. This entire system depends on a delicate balance. The water has to be just the right temperature, just the right saltiness, at just the right locations. And that balance is incredibly fragile. When the AMOC is running normally, it's remarkably stable. It's been operating more or less continuously for millions of years. But when it gets disrupted, it doesn't just slow down gradually. It can flip between different states almost instantly. Think of it like a light switch rather than a dimmer. It's either on or it's off. And right now, we're seeing warning signs that this switch might be getting ready to flip. The evidence is mounting, and it's not subtle. Since the 1,950 seconds, the AMOC has weakened by about 15%. That might not sound like much, but for a system this massive and stable, that's actually huge. It's like noticing that the Earth's rotation has slowed down by 15%. You'd be terrified, and rightfully so. Recent studies have found that the AMOC is at its weakest point in over 1,000 years. Ice core data suggests it might be at its weakest in 1,600 years. Oceanographers are measuring temperature and salinity changes that match exactly what their models predict would happen right before a collapse. But the most chilling evidence comes from the paleoclimate record. We know the AMOC has collapsed before. About 12,800 years ago, during what's called the Younger Dryas period, it shut down completely. The result was catastrophic. Europe plunged into ice age conditions almost overnight. Temperatures in some regions dropped by 10 degrees Celsius in just a few decades. Glaciers that had been retreating suddenly surged forward again. Entire ecosystems collapsed, And here's what keeps researchers awake at night. When the AMOC collapsed during the younger Dryas, it didn't give much warning. The transition happened incredibly quickly. Greenland ice cores show that some changes occurred within just a few years, some within months. So what would happen if it collapsed today? What would the first signs be? And how quickly would our world transform? The collapse wouldn't announce itself with sirens or breaking news alerts. Instead, the first signs would be subtle. Oceanographers monitoring temperature and salinity would notice their instruments showing strange readings. The conveyor belt wouldn't stop all at once. It would stutter like an engine misfiring before it dies. Within the first few weeks, satellite data would show something unprecedented. The sea surface temperatures in the North Atlantic would start changing in ways that have never been recorded in human history. The normally warm waters off the coast of Ireland and Britain would begin cooling, not gradually, but measurably, week by week. Marine biologists would be among the first to sound the alarm. Fish populations that depend on specific water temperatures would start behaving erratically. Cod would begin moving south. Tropical species that normally stay near the equator would start appearing in unusual locations. Whales would change their migration patterns, following the shifting temperature gradients. But the most dramatic early indicator would be visible from space. The Gulf Stream, normally a clearly defined river of warm water flowing north, would begin to weaken and meander. Satellite imagery would show the sharp temperature boundary that marks the edge of the Gulf Stream starting to blur and dissipate. Within a month, meteorologists would start noticing changes in weather patterns that don't make sense, according to their models. Storm systems would begin forming in unexpected places. The jet stream, which is influenced by ocean temperatures, would start wobbling in unprecedented ways. And then, somewhere around 6 to 8 weeks after the initial collapse, the first regional climate changes would become undeniable. Britain and Ireland would be the first to feel the impact, and it would be brutal. These islands owe their mild climate entirely to the warmth carried north by the AMOC. Without that heat source, they would rapidly shift toward a climate more like that of Labrador, which sits at the same latitude. The changes would be most dramatic in winter. London, which normally sees average January temperatures around 4 degrees Celsius, would plunge to -10 or -15 degrees. Scotland would become nearly uninhabitable in winter. But the cold wouldn't be the only problem. The collapse would fundamentally alter precipitation patterns across the region. The moisture that normally evaporates from the warm Gulf Stream would no longer exist. Much of Britain would shift from its famously wet climate to something much drier and more continental. The lush green landscapes that define the British Isles would begin browning within a single growing season. But Britain would just be the beginning. As the collapse progressed, its effects would cascade across the globe in ways that would reshape the climate of entire continents. Scandinavia would face even more severe changes. Norway, Sweden, and Denmark rely on the AMOC's warmth even more than Britain does. Without it, Scandinavia would return to Ice Age conditions. The Baltic Sea would freeze solid in winter for the first time in centuries. Major ports like Stockholm and Helsinki would become inaccessible for months at a time. The agricultural implications would be staggering. Northern Europe produces enormous amounts of food that feeds hundreds of millions of people. Grain production in regions that are currently temperate would become impossible. The growing season would shrink from 6 or 7 months to perhaps 3 or 4. Entire agricultural regions would have to be abandoned. But the effects wouldn't stop at temperature changes. The AMOC collapse would trigger a reorganization of atmospheric circulation patterns that would affect rainfall across 3 continents. The monsoon systems that bring life-giving rain to billions of people in Africa, India, and South America are all connected to the heat transport of the Atlantic circulation. The West African monsoon, which brings crucial rainfall to the Sahel region, would weaken dramatically. Countries like Niger, Chad, and Mali, which are already struggling with desertification, would face unprecedented drought. The Sahara Desert would begin expanding southward at an accelerated pace. Agricultural regions that currently support millions of people would transform into uninhabitable wasteland within a few growing seasons. In South America, the collapse would trigger changes to the Amazon rainforest that would be irreversible on human timescales. The Amazon depends on moisture that ultimately originates from Atlantic evaporation. With the AMOC shut down, rainfall patterns across the basin would shift dramatically. Parts of the rainforest would face severe drought, while other regions would experience unprecedented flooding as storm systems reorganized. The Amazon contains more biodiversity than anywhere else on Earth. It's also a crucial carbon sink, storing billions of tons of carbon in its trees and soil. As the forest began dying due to changed rainfall patterns, it would release massive amounts of carbon dioxide into the atmosphere, accelerating global warming and potentially triggering other climate tipping points. And all of this would be happening simultaneously, within months of the initial collapse. But perhaps the most terrifying aspect of an AMOC collapse wouldn't be the environmental changes themselves. It would be how quickly our interconnected global systems would begin falling apart under the strain of unprecedented climate disruption happening everywhere at once. The first dominoes would start falling in the global food system. Within 6 months of the collapse, crop failures would cascade across multiple continents simultaneously. Northern European wheat harvests would plummet as growing seasons shortened and temperatures plummeted. But it wouldn't just be the obvious cold regions that would suffer. Brazil's soy production, which feeds livestock around the world, would crater as rainfall patterns shifted across the Amazon basin. The precise timing of wet and dry seasons that farmers have depended on for generations would become completely unpredictable. Crops would either drown in unexpected floods or wither in droughts that arrive months earlier than ever before. India's rice production would face a double blow. The monsoon systems that have sustained agriculture for thousands of years would weaken and become erratic. At the same time, the Himalayan glaciers that feed India's major rivers would begin behaving unpredictably as global weather patterns reorganized. The timing of snowmelt, crucial for irrigation, would shift in ways that would catch farmers completely off guard. Within a single year, global food prices would skyrocket, not by the 20 or 30% increases we've seen during previous crises, but by 200, 300, even 500% for staple grains. Countries that import most of their food would face immediate shortages. Supply chains that took decades to build would crumble within months. But hunger would be just the beginning of the social collapse that would follow. Mass migration would begin almost immediately, but not in the gradual waves we might expect from slow climate change. This would be sudden, desperate, and overwhelming. Within 2 years of the collapse, we could see 50 to 100 million people on the move simultaneously. Northern Europeans would flee south as their homelands became uninhabitable. Scandinavians would pour into Germany and Poland. Britons would attempt to relocate to Spain, Portugal, anywhere that remained warm enough to sustain life. But these destination countries would be struggling with their own climate disruptions and massive influxes of climate refugees. In Africa, the situation would be even more catastrophic. As the Sahel dried up and the Sahara expanded, entire populations would be forced to migrate. But unlike previous droughts that affected specific regions, this would impact the entire breadth of sub-Saharan Africa simultaneously. Countries that might normally absorb refugees would be dealing with their own climate emergencies. The refugee camps would overwhelm every international aid organization. We're not talking about temporary displacement that lasts months or years. These would be permanent relocations of entire populations whose homelands had become uninhabitable. The international refugee system, already strained, would collapse entirely under the unprecedented scale of the crisis. Political systems would fracture under pressures they were never designed to handle. Governments would face impossible choices between helping their own citizens and accepting refugees. Resources that countries had planned to use for economic development would be redirected entirely toward emergency response and basic survival. In regions facing the most severe impacts, we'd likely see the complete breakdown of state authority. As agricultural systems collapsed and populations were forced to migrate, governments would lose their ability to collect taxes, maintain infrastructure, or provide basic services. Failed states would emerge not just in already fragile regions, but in countries that had been stable for decades. The economic implications would be staggering, beyond anything we've experienced in modern history. The 2008 financial crisis would look like a minor hiccup compared to the economic devastation that would follow an AMOC collapse. Global supply chains would shatter as ports froze over in Northern Europe and agricultural exports disappeared. The just-in-time manufacturing systems that define modern commerce depend on predictable transportation networks and stable suppliers. With massive climate disruptions happening simultaneously across multiple continents, these networks would collapse within months. Insurance companies would face claims that would bankrupt them almost instantly. Crop insurance, property insurance, business interruption insurance. The payouts would exceed the entire global insurance industry's reserves within the first year. The reinsurance market, which spreads risk globally, would collapse as risks became uninsurable. Energy systems would face unprecedented challenges. Hydroelectric dams in regions experiencing changed precipitation patterns would either run dry or face catastrophic flooding. Wind patterns that renewable energy systems depend on would shift unpredictably. Nuclear plants in regions facing extreme cold would struggle with cooling systems designed for different climate conditions. But perhaps most critically, the collapse would trigger a cascade of other climate tipping points that would accelerate the pace of change beyond anything we could adapt to. The Arctic sea ice, already under pressure from global warming, would face additional stress as ocean circulation patterns changed. Without the AMOC carrying heat north, some models suggest the Arctic could actually cool temporarily. But the disruption to ocean currents would destabilize ice sheets in ways we don't fully understand. The West Antarctic ice sheet, which contains enough ice to raise global sea levels by several meters, could become unstable as ocean circulation changes brought warmer water into contact with ice sheet edges. The precise mechanisms are complex, but the risk is real. An AMOC collapse could trigger ice sheet collapse that would flood coastal cities worldwide within decades rather than centuries. The Amazon rainforest, already under pressure from deforestation and drought, would face its own tipping point. As rainfall patterns shifted and temperatures changed, vast areas of rainforest would transition to savanna. This would release billions of tons of stored carbon, accelerating global warming and potentially triggering additional climate tipping points. The permafrost in Siberia and northern Canada, which stores enormous amounts of methane and carbon dioxide, would face destabilization as atmospheric circulation patterns changed. Even if these regions didn't warm significantly, changes in precipitation and seasonal timing could accelerate permafrost thaw, releasing greenhouse gases that would further destabilize the climate system. What makes this scenario so terrifying isn't just the individual impacts, but how they would interact and amplify each other. Each crisis would make every other crisis worse. Food shortages would drive migration, which would destabilize governments, which would make it impossible to respond effectively to climate impacts, which would worsen food shortages. The speed of these cascading effects would overwhelm our ability to adapt. Human societies are remarkably resilient when they have time to adjust. We've survived ice ages, volcanic eruptions, and massive climate shifts before. But those changes typically happened over centuries or millennia. An AMOC collapse would compress similar levels of change into decades or years. Our infrastructure, our institutions, our economic systems, none of them are designed to handle simultaneous massive disruptions happening at unprecedented speed across multiple continents. The redundancies and buffers that make modern civilization resilient assume that crises will be localized and temporary. An AMOC collapse would shatter those assumptions completely. And here's the most unsettling part. We still don't know exactly how fast it would happen. The paleoclimate record shows that previous AMOC collapses occurred rapidly, but the details are fuzzy. We know the end result: Ice Age conditions returning to Europe within decades. But we don't know if the transition took 5 years or 50. Recent research suggests it could happen faster than we ever imagined. Computer models that once predicted AMOC collapse over centuries now suggest it could happen within decades. Some show it happening within years of the tipping point being crossed. The question isn't whether an AMOC collapse would be catastrophic. The question is whether we would have any time at all to prepare for the fastest, most comprehensive reorganization of human civilization in recorded history. And that brings us to perhaps the most chilling realization of all. We're not just passive observers waiting to see what happens. Right now, today, we might already be living through the early stages of this collapse without even knowing it. The warning signs are subtle, but they're accelerating. Ocean monitoring stations across the Atlantic have been recording temperature and salinity changes that match exactly what climate models predict should happen in the years leading up to a collapse. The Greenland ice sheet is melting faster than ever before, pumping massive amounts of fresh water into the North Atlantic. That fresh water is less dense than salt water, which means it doesn't sink the way it should. And without that sinking, the entire circulation system begins to break down. But here's what makes this so insidious. The AMOC doesn't weaken in a straight line. It stutters. It fluctuates. It can seem to recover for months or even years before weakening again. Scientists call this flickering, the system oscillating unstably before it finally tips into a completely different state. We might be in that flickering phase right now. The unusually cold winters Europe experienced in recent years, the unprecedented heat waves, the erratic storm patterns, these could all be signs that the circulation system is becoming increasingly unstable. Each fluctuation could be bringing us closer to the point of no return. And that point of no return is what scientists call a tipping point. Unlike gradual climate change that happens over decades, tipping points are thresholds where systems flip rapidly from one stable state to another. Once you cross that threshold, there's no going back. Not for centuries, possibly not for millennia. Recent studies have tried to pinpoint exactly where that tipping point lies. The results are deeply unsettling. Some models suggest we could cross the threshold within the next 15 to 20 years if current trends continue. Others warn it could happen much sooner. A few suggest we might have already crossed it, and we're just waiting for the system to catch up with the new reality. Think about what that means. If you're in your 20s or 30s today, you could witness the collapse of one of Earth's fundamental climate systems within your lifetime. Your children would grow up in a world where the climate operates according to completely different rules than the ones that shaped all of human civilization. But the uncertainty around timing creates an almost paralyzing dilemma for policymakers and individuals alike. How do you prepare for something that might happen tomorrow or might happen in 50 years? How do you convince people to make sacrifices today for a catastrophe that might not occur in their lifetime? This uncertainty has led to what researchers call the procrastination penalty. Because we don't know exactly when the collapse might happen, it's tempting to assume we have more time than we actually do. But the nature of tipping points means that by the time we have certainty, it's already too late to prevent the collapse. We can only react to it, and our reactions would be constrained by infrastructure and institutions that were never designed for this kind of crisis. Take something as basic as emergency food reserves. Most countries maintain strategic reserves designed to last a few months during temporary disruptions. But an AMOC collapse would create food shortages that could last for years or decades. Our entire approach to emergency planning assumes that crises are temporary and localized. The same problem exists with refugee resettlement, economic policy, and international cooperation. Every system we've built to handle emergencies assumes that most of the world will remain stable and capable of helping affected regions. An AMOC collapse would create simultaneous emergencies across multiple continents, overwhelming our capacity to respond. Consider how Europe would handle the internal displacement of its own population. The European Union has struggled to manage a few million refugees from Syria and other conflict zones. An AMOC collapse could force tens of millions of Europeans to relocate within Europe as northern regions became uninhabitable. The political and logistical challenges would be staggering. Where would 60 million Britons go if their islands became as cold as Labrador? How would Spain and Portugal absorb millions of climate refugees while dealing with their own agricultural collapse as rainfall patterns shifted? How would Germany maintain its industrial economy while supporting massive refugee populations and dealing with its own climate disruptions? These aren't abstract policy questions. They're the kind of impossible choices that would tear apart the political systems we depend on for stability and cooperation. History shows us that societies under extreme stress often turn inward, becoming more nationalist and less cooperative precisely when cooperation is most essential. The economic disruptions would create their own cascade of political instability. As global trade collapsed and food prices skyrocketed, governments would face enormous pressure to prioritize their own citizens over international cooperation. Trade wars could escalate into actual conflicts as countries competed for dwindling resources. The most vulnerable populations would suffer disproportionately, as they always do. But an AMOC collapse would create new categories of vulnerability that cut across traditional lines of wealth and privilege. Residents of northern European cities, many of them affluent and educated, would suddenly find themselves climate refugees. Agricultural workers in currently temperate regions would lose their livelihoods not to economic forces they might eventually adapt to, but to physical climate conditions that made their work impossible. Small island nations, already threatened by sea level rise, would face additional challenges as storm patterns shifted and ocean currents changed. The precise impacts would depend on complex interactions between different climate systems. But many island communities could become uninhabitable, not just because of rising seas, but because of changes in precipitation, storm intensity, and ocean temperature that would devastate local ecosystems. Perhaps most tragically, indigenous communities that have adapted to specific climate conditions over thousands of years would face the loss of their traditional lands and ways of life. The Inuit of the Arctic, the Sami of northern Scandinavia, indigenous communities across northern Canada and Siberia. Their cultures are intimately connected to climate patterns that would be fundamentally altered by an AMOC collapse. But even as we grapple with the scale of potential suffering, we have to confront an uncomfortable truth about human nature. Historical evidence suggests that societies facing existential threats don't always respond with increased cooperation and rational planning. Sometimes they fragment. Sometimes they turn to authoritarianism. Sometimes they lash out at convenient scapegoats rather than addressing root causes. The rise of climate authoritarianism is already visible in how some governments respond to climate-related migration and resource scarcity. An AMOC collapse would accelerate these trends dramatically. Democratic institutions that depend on stability and gradual change could prove inadequate to handle rapid, simultaneous crises across multiple domains. Military analysts have begun studying how armed forces would respond to climate breakdown scenarios. Not just natural disasters that require humanitarian assistance, but fundamental breakdowns of social order that would require military intervention to maintain basic security. The scenarios are sobering. Military resources that seem vast in normal times would be quickly overwhelmed by simultaneous emergencies across vast geographic areas. International institutions like the United Nations, NATO, and the European Union would face pressures that could tear them apart. These organizations work because member nations believe cooperation serves their interests better than going it alone. But extreme climate disruption could change that calculation rapidly. Nations facing existential threats to their own survival might withdraw from international commitments to focus on domestic emergencies. The breakdown of international cooperation would make every other aspect of the crisis worse. Scientific research requires international collaboration to monitor global systems and develop solutions. Refugee resettlement requires coordinated international response. Managing cascading economic crises requires unprecedented cooperation between central banks and governments. Climate adaptation requires sharing of technology and resources across borders. An AMOC collapse wouldn't just be an environmental crisis or even a humanitarian crisis. It would be a crisis of human civilization itself. The networks of trade, communication, cooperation, and mutual dependence that define modern life would face stresses they were never designed to handle. And yet, understanding these cascading risks also points toward what our response needs to look like. If the danger lies in simultaneous system failures, then resilience requires building redundancy across all our critical systems. If the threat is speed of change overwhelming our adaptive capacity, then we need to accelerate our preparation for multiple scenarios. The most important realization might be that preparing for an AMOC collapse isn't really about predicting exactly when or how it would happen. It's about building societies that can handle rapid, unprecedented change, regardless of the specific trigger. Whether the crisis comes from ocean circulation, collapse, solar storms, pandemic, or some combination of factors we haven't anticipated, the underlying challenge is the same. We need food systems that can adapt quickly to changing conditions. We need energy systems that don't depend on stable climate patterns. We need economic systems that can function during supply chain disruptions. We need political systems that can maintain legitimacy and effectiveness during prolonged emergencies. Most importantly, we need social systems that can maintain cooperation and mutual aid when resources become scarce and uncertainty becomes the norm. The communities that would be most likely to survive and thrive through an AMOC collapse wouldn't necessarily be the wealthiest or most technologically advanced. They would be the ones with the strongest social bonds, the most diverse skill sets, and the greatest capacity for collective decision-making under stress. This brings us to a paradox that lies at the heart of climate risk. The very interconnectedness that makes modern civilization so productive and efficient also makes it incredibly vulnerable to cascading failures. Our just-in-time supply chains, our specialized economies, our urbanized populations, all of these represent tremendous achievements that have lifted billions out of poverty and created unprecedented prosperity. But they also represent single points of failure that could bring down entire regions if disrupted simultaneously. An AMOC collapse would test whether human civilization has become too complex and interconnected for its own good, or whether our networks of cooperation and mutual dependence would prove resilient enough to help us adapt to a fundamentally changed world. The answer to that question may determine not just how many people would survive an AMOC collapse, but what kind of civilization would emerge on the other side. Would we rebuild using the same principles of efficiency and interconnectedness that made us vulnerable in the first place? Or would we create something more resilient, more localized, more adapted to living with uncertainty and rapid change? These aren't just questions for policymakers and scientists. They're questions every community, every family, every individual needs to grapple with. Because if an AMOC collapse teaches us anything, it's that the future is far less predictable than we like to believe, and our survival may depend on how well we prepare for possibilities we hope will never come to pass. The psychological impact of living through such rapid, fundamental change would be unlike anything our species has experienced. Think about how disorienting it feels when your daily routine gets disrupted for just a week. Now, imagine that everything you thought you understood about how the world works, the seasons, the weather patterns, where food comes from, which places are safe to live, all of that knowledge becoming obsolete within a few years. Entire professions would disappear overnight. Meteorologists would find their decades of training useless as weather patterns shifted into configurations that had never been recorded. Agricultural experts would watch crop varieties they'd spent careers perfecting fail completely in new climate conditions. Coastal engineers would see sea level projections become meaningless as ocean circulation patterns reorganized. But it's not just professional knowledge that would become obsolete. Cultural knowledge passed down through generations would suddenly become irrelevant. Farmers would discover that planting schedules their families had followed for centuries no longer worked. Fishermen would find that the seasonal patterns of fish migration their grandfathers taught them had completely changed. Indigenous communities would lose traditional ecological knowledge that had been refined over thousands of years. The speed of change would prevent the gradual adaptation that has allowed human societies to survive climate shifts in the past. When climate change happens over centuries, each generation can pass on modified knowledge to the next. Children grow up learning slightly different patterns from their parents. But when change happens within a few years, there's no time for that gradual cultural evolution. Instead, we'd face what psychologists call learned helplessness on a global scale. When people's understanding of cause and effect breaks down repeatedly, they often stop trying to predict or control outcomes. They become passive and fatalistic. This psychological response, multiplied across billions of people simultaneously, would make effective collective action nearly impossible precisely when it would be most desperately needed. The mental health implications would be staggering. Anxiety disorders would spike as people faced constant uncertainty about basic survival needs. Depression would become endemic as communities lost their sense of place and purpose. Post-traumatic stress wouldn't just affect direct victims of climate disasters. It would spread through entire populations as people witnessed the collapse of everything they thought they could count on. Children would be particularly vulnerable. Child development depends on predictable environments where cause and effect relationships can be learned and trusted. Children growing up during an AMOC collapse would face constant upheaval during the years when their brains are forming their basic understanding of how the world works. The psychological scars could last for generations, but perhaps the most insidious effect would be the breakdown of social trust. Modern society depends on millions of strangers cooperating because they trust that shared institutions will enforce agreements and maintain order. When those institutions prove unable to handle cascading climate crises, social trust erodes rapidly. We've already seen hints of this during much smaller disruptions. Natural disasters often bring communities together initially, but prolonged stress fractures social bonds. When resources become scarce and institutions fail, people retreat into smaller and smaller circles of trust. They prioritize their immediate family, then their community, then their region or ethnic group. Cooperation with outsiders becomes seen as a luxury they can't afford. This social fragmentation would make every other aspect of the crisis worse. Scientific research requires trust between researchers across different institutions and countries. Economic recovery requires trust between traders, lenders, and investors. Political solutions require trust that different groups will honor agreements even when it's costly to do so. An AMOC collapse would occur at a time when many societies already face declining social trust due to political polarization, economic inequality, and rapid technological change. The additional stress of climate breakdown could push trust levels below the threshold needed for complex societies to function effectively. The generational impacts would be profound and lasting. People who lived through the collapse would carry trauma that would shape their worldview for the rest of their lives. They would be hypervigilant about environmental changes, reluctant to depend on complex systems, and deeply skeptical of assurances that things had returned to normal. These psychological changes wouldn't just be individual responses, they would reshape entire cultures. Societies that survived an AMOC collapse would develop new myths, new values, and new ways of organizing themselves that reflected the experience of living through rapid system collapse. Trust in expertise would be replaced by faith in local knowledge. Long-term planning would give way to focus on immediate resilience. The children born during and after the collapse would grow up in a world where climate instability was normal. They would develop different relationships with nature, different expectations about the future, and different ideas about what constitutes security and success. In some ways, they might be better adapted to the new reality than adults who remember the old world, but they would also inherit societies traumatized by loss and focused on survival rather than flourishing. Educational systems would face complete reorganization. What's the point of teaching children about historical climate patterns that no longer apply? How do you prepare students for careers in a world where the basic parameters of human civilization are shifting rapidly? Traditional education assumes a relatively stable future where accumulated knowledge remains relevant. An AMOC collapse would shatter that assumption. Instead, education would need to focus on adaptability, resilience, and the ability to learn rapidly in changing conditions. Students would need to master not just specific skills, but the ability to quickly acquire new skills as circumstances changed. They would need to understand systems thinking, risk assessment, and community organization rather than specialized technical knowledge that might become obsolete. The collapse would also force humanity to confront some uncomfortable truths about our relationship with the natural world. For centuries, we've operated under the assumption that nature provides a stable backdrop against which human drama unfolds. We've built our cities, our economies, and our institutions as if climate conditions would remain roughly constant. An AMOC collapse would reveal that assumption to be dangerously naive. Nature isn't a stable backdrop, it's a dynamic system that can shift rapidly between different states. Human civilization isn't separate from natural systems. It's embedded within them and completely dependent on their continued functioning. This realization would force a fundamental shift in how we think about progress, development, and success. The metrics we've used to measure human achievement, GDP growth, urbanization rates, technological advancement, would prove inadequate for a world where basic climate stability could no longer be taken for granted. New measures of success would emerge that prioritized resilience over efficiency, local self-sufficiency over global integration, and adaptive capacity over optimization for current conditions. Communities would be judged not by how much wealth they could accumulate during good times, but by how well they could maintain social cohesion and basic services during prolonged stress. The technological implications would be equally profound. Many of our most sophisticated technologies depend on supply chains and manufacturing processes that assume climate stability. Computer chips require precisely controlled environments. Solar panels depend on predictable weather patterns for optimal placement. Wind turbines are designed for specific wind patterns that might change completely. An AMOC collapse would force rapid innovation in technologies designed for unstable conditions. We'd need crops that could adapt quickly to changing growing seasons. We'd need building techniques that could handle unprecedented weather extremes. We'd need communication systems that could function when traditional infrastructure failed. But perhaps more importantly, we'd need to rediscover technologies and techniques that our ancestors used before the era of climate stability. Traditional building methods that could handle extreme weather without external energy inputs. Food preservation techniques that didn't depend on reliable electricity, navigation methods that didn't require satellite systems. The collapse would create a strange mixture of high technology and pre-industrial techniques as communities tried to maintain some modern capabilities while adapting to much more variable conditions. Solar panels might power LED lights in buildings constructed using ancient earthen techniques. Satellite communication might coordinate the distribution of food preserved using methods that hadn't changed in centuries. This technological mixing would create new forms of innovation as engineers and inventors found ways to combine modern knowledge with traditional resilience. Communities that successfully navigated this transition might emerge stronger and more capable than before, though the cost in human suffering during the transition would be enormous. The religious and philosophical implications would be equally significant. Many contemporary belief systems assume that human progress is generally linear and that technology can solve most problems given enough time and resources. An AMOC collapse would challenge these assumptions fundamentally. Some religious traditions that emphasize human stewardship of creation or the interconnectedness of all life might find renewed relevance. Others that promise earthly prosperity or technological transcendence might face serious crises of faith. New spiritual movements would likely emerge that try to make sense of rapid environmental change and social upheaval. Philosophical frameworks would need to grapple with questions that had seemed abstract or distant. What do we owe to future generations when our own survival is uncertain? How do we make ethical decisions when traditional moral frameworks assume stable conditions? What does human dignity mean when basic survival becomes the primary concern for most people? These aren't just academic questions. The answers would shape how communities organize themselves, how resources were distributed, and how conflicts were resolved. Societies with philosophical frameworks better adapted to uncertainty and rapid change would have significant advantages over those clinging to assumptions that no longer applied to reality. The arts would play a crucial role in helping people process such fundamental change. Literature, music, visual arts, and storytelling would become vehicles for working through collective trauma and imagining new possibilities. Artists would help communities mourn what was lost while envisioning what might be rebuilt. But traditional artistic institutions, museums, concert halls, universities, might struggle to survive when basic survival needs took priority over cultural activities. Art would need to find new forms and new venues that could function in less stable conditions. Street art, folk music, storytelling traditions, and community theater might prove more resilient than institutions that required significant infrastructure and specialized funding. The collapse would also reveal which aspects of human culture are truly essential and which are luxuries that depend on abundance and stability. Some traditions and practices would prove remarkably resilient, surviving because they served important social functions, even under stress. Others would disappear rapidly when the conditions that supported them changed. This cultural winnowing would be both tragic and potentially liberating. Communities would lose cherished traditions and ways of life that had defined their identities for generations. But they would also be freed from cultural practices and expectations that might have been holding them back from adapting to new realities. The languages that survived an AMOC collapse would be those that proved most useful for coordination and cooperation under stress. Technical vocabularies developed for stable conditions might disappear, while traditional knowledge about weather patterns, seasonal changes, and resource management would become precious cultural inheritance. New languages and communication methods might emerge as communities developed ways to share information about rapidly changing conditions. Scientific terminology would mix with traditional knowledge systems in ways that created entirely new vocabularies for describing and responding to environmental change. Through all of this upheaval, certain fundamental human needs would remain constant. People would still need food, shelter, safety, and social connection. They would still fall in love, raise children, create beauty, and seek meaning. But the contexts in which these universal human experiences played out would be transformed beyond recognition. The question isn't whether humanity would survive an AMOC collapse. Our species has survived ice ages, volcanic winters, and massive environmental changes before. The question is, what kind of humanity would emerge from such a rapid and comprehensive transformation of the conditions that have shaped our civilization? Would we emerge more humble about our place in natural systems, more focused on resilience and mutual aid, more adapted to living with uncertainty? Or would the trauma of collapse lead to more authoritarian, more insular, more conflict-prone societies? The answer would depend partly on how well we prepare for such possibilities, but also on choices we would make during the crisis itself about what values to preserve and what new directions to pursue. The children who would grow up after an AMOC collapse would inherit a world transformed by the largest reorganization of human civilization in recorded history. Whether that world would be one of greater wisdom and sustainability or simply one of survival and scarcity would depend on decisions we might need to make much sooner than we realize. And that's perhaps the most sobering realization of all. We're not just passive observers, waiting to see whether this catastrophe will occur. We're active participants in systems that are determining right now whether such a collapse becomes inevitable, how quickly it might unfold, and how prepared we'll be if it arrives. The warning signs are accelerating, the risks are mounting, and the window for prevention may be narrowing faster than we dare to admit. The signals are becoming harder to ignore. In the past 5 years alone, we've seen temperature anomalies in the North Atlantic that oceanographers describe as unprecedented, not just warmer than average, but following patterns that match exactly what computer models predict should happen in the final years before system collapse. The Greenland ice sheet is now losing ice at a rate of over 280 billion tons per year. That's not just a number in a scientific paper. That's 280 billion tons of fresh water pouring into the precise location where the AMOC depends on dense, salty water to sink and drive the entire circulation system. Every year, we're essentially dumping the equivalent of Lake Erie into the engine room of the planet's climate system. But what makes this truly terrifying is that we're not just approaching the tipping point gradually. Recent research suggests we might be experiencing what scientists call early warning signals, subtle changes in how the system responds to disturbances that indicate it's becoming critically unstable. Think of it like a chair that's about to break. Before it collapses completely, it starts to creak and wobble when you shift your weight. The AMOC is showing signs of that same kind of instability. Ocean temperatures are fluctuating more wildly than they have in decades. Salinity levels are showing unprecedented variability. The system is creaking. Marine ecosystems are already responding to these early warning signals in ways that should alarm anyone paying attention. Cod populations off the coast of New England have shifted their range northward by hundreds of miles in just the past decade. Lobster fishermen in Maine are finding tropical species in their traps that have never been seen that far north before. Whale migration patterns are becoming increasingly erratic as the temperature boundaries they navigate shift unpredictably. Seabird colonies are experiencing reproductive failures as the fish they depend on follow changing water temperatures into new areas. These aren't gradual adaptations to slowly changing conditions. These are emergency responses to a system that's already becoming unstable. But perhaps the most chilling indicator comes from deep ocean monitoring stations that most people have never heard of. Arrays of sensors scattered across the Atlantic floor have been recording changes in deep water flow patterns that suggest the bottom portion of the circulation system is already weakening significantly. The deep water that normally flows south along the ocean floor, completing the circulation cycle, is moving more slowly and carrying different temperature and chemical signatures than it has at any point since monitoring began. This is the equivalent of checking someone's pulse and finding it weak and irregular. It doesn't necessarily mean cardiac arrest is imminent, but it's definitely not a good sign. What makes these warning signs so ominous is that they're accelerating. Changes that took decades to manifest in the 20th century are now happening within just a few years. The pace of destabilization is increasing, which suggests we might be much closer to the tipping point than even the most pessimistic projections have predicted. And here's where the story takes a personal turn. Because this isn't just about abstract climate data or computer models. This is about you, right now, making decisions about your life based on assumptions about the future that might be completely wrong. If you're in your 20s, you're making career choices, relationship decisions, and financial plans based on the assumption that the world in 2050 will be roughly similar to the world today. Maybe a bit warmer, maybe more expensive, but fundamentally recognizable. An AMOC collapse would make those assumptions catastrophically wrong. If you're buying a house, you're probably thinking about local factors like school districts and commute times. You're probably not considering whether the region you're moving to would be habitable if European agricultural systems collapsed and hundreds of millions of climate refugees needed somewhere to go. But maybe you should be. If you're planning to have children, you're imagining raising them in a world that operates according to roughly the same rules as the one you grew up in. You're thinking about their education, their opportunities, their futures. But what if they need to be prepared for a world where basic survival skills matter more than advanced degrees? These aren't comfortable questions, and there are no easy answers. But ignoring the possibility doesn't make it go away. It just ensures that we'll be completely unprepared if it happens. The psychological challenge of living with this kind of uncertainty is unlike anything our species has faced before. Previous generations dealt with immediate threats they could see and respond to. Wars, famines, diseases, these were terrible, but they were comprehensible. You could fight back or flee or take shelter and wait for them to pass. But how do you prepare for the possibility that the fundamental systems that support human civilization might change faster than we can adapt? How do you live with the knowledge that we might be in the final decades or years or even months of climate stability as we've known it? Some people respond to this uncertainty by throwing themselves into activism, trying to prevent the collapse through rapid decarbonization and climate action. Others retreat into denial, refusing to acknowledge the possibility because it's too overwhelming to contemplate. Still, others become prepper enthusiasts, stockpiling supplies and learning survival skills for a post-collapse world. But there might be a fourth response that's more psychologically sustainable and practically useful: radical acceptance combined with intelligent preparation. This means accepting that we can't control whether the AMOC collapses, but we can control how we respond to that uncertainty. This approach would involve making life choices that make sense whether the collapse happens or not, learning skills that would be valuable in both stable and unstable futures, building relationships and communities that could provide support through either gradual change or sudden crisis, creating forms of resilience that enhance life even if the worst-case scenarios never materialize. What would this look like in practice? It might mean learning to grow food even if you live in a city. Not because you expect to become a subsistence farmer, but because understanding food systems makes you more resilient and self-reliant regardless of what happens to global supply chains. It might mean developing skills in conflict resolution, community organizing, and mutual aid. These abilities would be invaluable during any kind of crisis, but the CFA during normal times. It also make communities stronger, and more might mean choosing where to live based not just on current opportunities, but on long-term resilience factors. Access to fresh water, local food production, renewable energy potential, and strong social networks. Places that could adapt and thrive even if larger systems become unstable. It might mean rethinking what constitutes wealth and security. Instead of optimizing for maximum income in specialized careers, it might mean developing diverse skill sets and multiple income streams that wouldn't all disappear simultaneously during system disruptions. Most importantly, it might mean building the kind of communities that could maintain cooperation and mutual support even under extreme stress. Because ultimately, human survival isn't just about individual preparation. It's about collective resilience. The communities that would be most likely to thrive through an AMOC collapse wouldn't necessarily be the wealthiest or most technologically advanced. They would be the ones with the strongest social bonds, the most diverse local economies, and the greatest capacity for collective decision-making and mutual aid. This is where individual preparation intersects with larger questions about how our societies should evolve. If we take the possibility of rapid climate disruption seriously, it changes how we think about everything from urban planning to education policy to international relations. Cities would need to become more self-sufficient in food and energy production. Educational systems would need to prioritize adaptability in systems thinking over narrow specialization. International agreements would need to focus on cooperation and resource sharing, rather than just trade and military alliances. But these larger changes would need to happen while we're still uncertain about timing and specific impacts. We'd be preparing for scenarios we hope will never occur, using resources we might need for other priorities, all while maintaining the current systems that billions of people depend on for their daily survival. This is the cruel paradox of prevention. The actions needed to reduce the risk of AMOC collapse would require massive global coordination and investment at a time when many societies are already struggling with immediate challenges. It's asking people to make sacrifices today for benefits that might not be realized for decades, if ever. And yet, the alternative might be facing the fastest, most comprehensive reorganization of human civilization in recorded history, with almost no preparation at all. The window for preventing an AMOC collapse entirely might already be closed. Even if we stopped all greenhouse gas emissions tomorrow, the momentum already built into the climate system means we'd likely see continued warming and ice sheet melting for decades. The fresh water already entering the North Atlantic might be enough to trigger the collapse regardless of what we do now. But that doesn't mean our choices don't matter. Even if we can't prevent the collapse, we might be able to influence how quickly it happens and how severe the impacts become. More importantly, we can certainly influence how prepared we are to handle whatever changes are coming. The difference between a gradual AMOC weakening over several decades and a rapid collapse within a few years might be the difference between adaptation and catastrophe. The difference between communities that have prepared for climate disruption and those that haven't might be the difference between resilience and social breakdown. These aren't abstract policy questions anymore. They're immediate, practical considerations that should be influencing decisions being made right now in every community, every institution, and every family. The most unsettling aspect of our current situation might be that we're making these crucial decisions with incomplete information under unprecedented time pressure. We don't know exactly when the tipping point might be reached, how quickly the collapse would unfold, or precisely what the regional impacts would be. But we do know that the risks are real, the potential consequences are severe, and the warning signs are accelerating. We know that preparation takes time, and that waiting for certainty means waiting too long. We also know that the same actions that would help us survive an AMOC collapse would make our communities stronger and more resilient regardless of what climate challenges we face. Building local food systems, developing renewable energy, strengthening social networks, learning practical skills, these things improve quality of life and community resilience under any circumstances. Perhaps that's the key insight. Instead of trying to predict exactly what will happen and when, we can focus on building the kind of adaptive capacity that would serve us well across a range of possible futures. We can create communities and institutions that are antifragile, blank, that don't just survive disruption, but actually become stronger because of it. This isn't about retreating from modern civilization or abandoning the benefits of global cooperation and technological advancement. It's about building redundancy and resilience into the systems we depend on, while maintaining our capacity for innovation and adaptation. The children growing up today will inhabit a world shaped by how we respond to these challenges over the next decade or two. They'll inherit either societies that prepared thoughtfully for an uncertain future, or communities that were caught off guard by changes they should have seen coming. The choice isn't between preventing climate change and adapting to it. At this point, we need to do both simultaneously while preparing for the possibility that our efforts might not be sufficient to prevent major system disruptions. What we're really choosing is whether to face these challenges proactively with preparation and community solidarity, or reactively, with panic and social fragmentation? Whether to build resilience before we need it, or to improvise solutions during emergencies when resources are scarce and cooperation is most difficult. The AMOC collapse scenario forces us to confront the ultimate question about human civilization. Are we capable of long-term thinking and cooperative action when faced with unprecedented challenges? Or are we doomed to repeat the pattern of ignoring problems until they become crises, then responding with too little, too late? The answer to that question will determine not just whether we survive potential climate tipping points, but what kind of species we prove ourselves to be when tested by the consequences of our own success. Right now, as you're watching this video, ocean monitoring stations across the Atlantic are recording data that could tell us we've already crossed the point of no return. Temperature sensors buried deep in the Labrador Sea, salinity measurements from research vessels crossing the Denmark Strait, current meters anchored to the ocean floor between Greenland and Scotland, they're all sending signals that match the early warning patterns climate models have been predicting for decades. But here's the thing that makes this so much more personal than any abstract climate discussion. The data isn't just showing gradual change anymore. It's showing acceleration. The kind of acceleration that suggests we might not have the luxury of decades to prepare for this transition. In the past 18 months alone, we've seen temperature fluctuations in the North Atlantic that oceanographers describe as unprecedented in the observational record. We're not talking about measurements that are slightly outside normal ranges. We're talking about readings that are so far beyond historical norms that scientists are having to recalibrate their instruments to make sure they're working properly. The Greenland ice sheet is now losing mass at a rate that's doubled since 2010. That's not a gradual trend line. That's exponential acceleration. Every summer breaks the previous record for ice loss. Every winter fails to fully replenish what melted the previous year. The system is spiraling away from equilibrium in real time. But perhaps, most ominously, we're starting to see what researchers call flickering, rapid oscillations between different states that typically occur just before a system tips into a completely new configuration. Ocean temperatures in key regions are swinging between extremes more wildly than they ever have since we started keeping records. The circulation system is becoming increasingly unstable, like a spinning top just before it topples over. Marine life is responding to these changes in ways that suggest they're sensing something we're only beginning to measure scientifically. Whales are changing their migration routes in patterns that make no sense according to current temperature maps, as if they're following water masses that are shifting faster than our monitoring systems can track. Seabirds are abandoning nesting colonies they've used for centuries, apparently responding to changes in ocean productivity that our satellites are just beginning to detect. Deep-sea fish species that have never been seen in certain regions are suddenly appearing in fishing nets thousands of miles from their normal ranges. It's as if the entire ecosystem is responding to signals we can't yet fully interpret, but that clearly indicate the ocean system is already in transition. The psychological weight of living with this knowledge is something most people haven't had to grapple with yet, but it's coming. Because once you understand how close we might be to this tipping point, once you realize that the early warning signs are already flashing red, you can't unknown it. Every unusual weather pattern starts to feel like a potential harbinger. Every new scientific study becomes a source of anxiety rather than curiosity. Every long-term plan you make for your life carries the shadow of uncertainty about whether the world those plans assume will still exist. This isn't climate anxiety in the abstract sense that many people experience when they think about global warming as a distant future threat. This is the specific, visceral realization that you might be living through the final years or even months of climate stability as we've known it throughout human history. And yet, paradoxically, this knowledge also carries a strange kind of clarity, Because once you accept that we might be approaching a fundamental discontinuity in human experience, it changes how you prioritize everything. The career moves that seem so important start to feel less urgent. The relationships and communities that would matter during a crisis start to seem more valuable. The skills that would be useful in an uncertain world become more worth learning than the ones optimized for the world we're leaving behind. There's something almost liberating about accepting that the future might be radically different from the present. It frees you from the assumption that you need to optimize your life for the continuation of current trends. Instead, you can start preparing for a world where adaptability matters more than specialization, where community resilience trumps individual achievement, where practical skills count more than credentials. But this psychological shift also comes with profound responsibility, because if we really are in the final window before potential system collapse, then every choice we make right now carries enormous weight, not just for our own futures, but for the communities we're part of and the children who will inherit whatever world emerges from this transition. The communities that are already beginning to prepare for this possibility aren't waiting for government directives or international agreements. They're quietly building the kind of resilience that would serve them well regardless of what specific challenges emerge. Local food networks, renewable energy cooperatives, skill-sharing organizations, mutual aid societies, the infrastructure of community self-reliance that would be invaluable during any kind of prolonged crisis. These aren't survivalist compounds or doomsday prepper enclaves. They're ordinary communities that have decided to reduce their dependence on systems they can't control while strengthening their connections with people they can depend on. They're creating the kind of social fabric that could hold together under stress while maintaining the values and practices that make life worth living. The most unsettling truth about an AMOC collapse isn't that it might happen. It's that we're already living in the time when it could happen, making decisions about our lives and communities while the early warning signals flash all around us. Whether this system tips next year, next decade, or holds on for another generation, the question isn't really about timing anymore. It's about whether we'll choose to build the kind of resilience that could carry us through whatever comes next, or continue betting everything on a stability that may already be slipping away.